Alright, 1C, relations and functions, and we're actually going to pause right here, right at the beginning, because this should be a review for you labeling axes and quadrants. So I want you to pause here and do these 5 questions in your notes. Label those things and then plot the ordered pair. Okay, so maybe without the cool colors that mine has, but hopefully you were able to label these things correctly. The x-axis is the horizontal axis, this green one. The y-axis is the vertical axis. When we label the quadrants, quadrant 1 is at the top right, okay? And we do them with Roman numerals, and then it goes counterclockwise. So this is 1, this is 2, this is 3, this is 4. The origin is right here. It is 0, 0. And then you had to plot the ordered pair 2, 3. So the x-coordinate is first, is 2. The y-coordinate comes second, it's 3. So I went to 2 on the x-axis, and then up 3 on the y-axis, and that right there is the point 2, 3. So that was just a quick review on the coordinate plane and graphing things. And now we're going to look at relations. So a relation is just a set of ordered pairs. Anytime we have more than one ordered pair, that becomes a relation. And we have 4 different ways that we can represent a relation. It's a set of ordered pairs, so of course we can represent it with ordered pairs. So I just came up with 4 ordered pairs here that these are my relation. We can also write these ordered pairs in a table. We can plot these ordered pairs on a graph, and we can put them in what's called a mapping. So if I have ordered pairs in a table, in my table I have one column for the x values, one column for the y values, and the x and y value that go together are next to each other in the table. So I just copy exactly how they are written, the values into the table. Alright, if I graph them, of course I'm going to plot these points. So 1, 3, 2, 4, negative 2, 3, and 0, negative 1. So I just draw a plot. Okay, when we have a mapping, we put the x values in one circle, the y values in another circle. Usually we're going to put these in numerical order. So if I look at all my x values, negative 2 is the smallest one, and then it goes to 0, then 1, and then 2. And then in my y values, my smallest y value is negative 1, and then I have 3. Now that 3 appears twice, but I'm not going to write it twice in the mapping because I'm going to end up drawing arrows. So I'm only going to write 3 once, and then I also have 4. Then for a mapping, you just draw an arrow between the points that are connected. So negative 2 goes with 3, so I draw an arrow. 0 goes with negative 1, so I draw an arrow there. 1 goes with 3, so I draw an arrow to 3, and then 2 goes with 4, so it gets an arrow straight across. We can also use an equation to represent a relation, so I could say like 2x plus 4 is a relation, and then I would have my different x and y values to make ordered pairs. Then a function is a special kind of relation. So in a function, there is exactly one output or y value for each input or x value. Alright, another way of saying that is that the x values cannot repeat. Okay, so if I have as one of my inputs or one of my x values, I have 2. And then the y value that goes with 2 is 5. Then I cannot later on in my set of ordered pairs have another 2 as an x value and then 7 as a y value, okay? Because then that x value has 2 different y values that go with it, and that would make it not a function. Alright, so depending on the way that our relation is represented, there's different ways to determine if it is also a function. So if I'm looking at a set of ordered pairs, or if I'm looking at a table, I'm looking for repeating x values. If there is an x that appears twice in a table, it is not a function. If there's an x that appears twice in a list of ordered pairs, then that relation is not a function. In a mapping, we're looking for, does an x value have arrows going to more than one number? So if I have 2 in the x circle in a mapping, and it has 2 arrows coming out of it going to 2 different numbers, that would not be a function. If you're looking at a graph, we're going to do something called the vertical line test, and I will show you exactly what that looks like when we get to those examples at the bottom. But you're looking for a vertical line to only touch the graph in one spot at a time. Okay, so let's look at some examples. Alright, the first thing we have here is a mapping. And see, -4 only has 1 arrow, -2 only has 1 arrow, 0 only has 1 arrow, 2 only has 1 arrow, and 4 only has 1 arrow. So yes, this is a function because each x value only has 1 arrow pointing to a y value. Now, if you look at the y values, there are 2 arrows pointing to -1, and there are 2 arrows pointing to 4. That is okay. Y values are allowed to be repeated in a function, alright, but x values cannot be repeated. Over here we have a table, and I'm looking at the x values, 2, 5, 6, and 6. The 6 is repeated, and look, it has 2 different y values, 6, 9, and 6, 10. That can't happen in a function, so this one, no, is not a function. Here I have a list of ordered pairs, so let's look at the x values. I have 2, -1, 5, and 2. Well, that 2 appears twice. That is not allowed in a function, so no, that one is not. Okay, we're going to skip the line for now. We'll do that in a later chapter. Okay, now we're going to look at some graphs. And here's what I mean by the vertical line test. So I have this straight up and down line. You might want to take your pencil, set your pencil up, and run it across the graph. So if I move this vertical line across the graph, where does it touch the blue? There, it only touches 1 blue dot. There, it only touches 1 blue dot. Here, it touches 2 blue dots at the same time. This one up here and this one down there. That means that this is not a function, okay, because it touches a vertical line in 2 places at the same time. All right, here's why the vertical line test works. If I were to write the ordered pair for this dot, it is at 0, 1, 2, 3, 4, 5, 6, 0, 6. The ordered pair for this dot is at 0, 1. So that means I have 2 of the same x value with a different y value, which is not allowed. Okay, so the vertical line test, if it touches in more than one place at a time, it is not a function. Alright, now we'll look at this example. I'm going to take my vertical line and just slide it along, and everywhere it's on the blue, make sure that it's only touching at one spot. So this is one spot, one spot, one spot. It's only touching that blue line in one place all the way across. So that means that this graph, yes, this is a function because the vertical line only touches that blue graph in one spot at a time. So what I want you to do is try 7 and 8 here. Just take your pencil and use it as a vertical line, run it straight across the graph, and see if it touches in more than one place at anywhere on the graph. Alright, remember I said we could also use an equation to write a relation, and if we have a function, alright, that's written in an equation, we can also write it in another form called function notation. Alright, so this here would be an equation form, y equals 3x minus 8. And then in function notation, it becomes f parentheses x, and we read that as f of x. So f of x equals 3x minus 8. So we're going to look at that a little closer and break it down. This is function notation. We would read this as f of x equals 3x minus 8. Okay, that's what it would look like written out, and that's how you would read it if you were talking about it in class. You would read this as f of x. Okay, so f is just the name of the function. We can call a function f of x, g of x, h of x. We can use really any letter we want. A lot of the time you're going to see f. So this is the name of this function. This is function f. Whatever is inside the parentheses is the input. So that's what we're going to put into the function. So in this case it's f. We can also replace the x with a number. So I could tell you, just like we did earlier in this chapter, that x is 4. And we could put a 4 in the parentheses, which would mean 4 is the input and 4 goes into the function. 3x minus 8 is the rule that is used by the function. So the function f uses 3x minus 8. Whatever we put into the function, whatever number is the input, gets run through that rule. So if I put 2 into this function, I would do 3 times 2 minus 8, because 3 times the input minus 8 is the rule for this function. And then lastly, whatever's on the left side, so f of x is the output, or you might hear it called the value of the function. So this is the result after the input goes through the rule. So let's say, for example, that I asked you to find f of 2. Alright, if I ask you to find f of 2 or evaluate f of 2, I'm telling you that 2 is the input. So I want you to put 2 into this rule and tell me what the value of it is after we simplify it and put it through the rule. So f of 2 means I'm going to evaluate the function at 2. I'm going to put 2 in place of my input, and then I'm going to see what it's worth. Alright, and what it's worth is 3 times 2 is 6, and 6 minus 8 is negative 2. So the value of the function at 2, or f of 2, is equal to negative 2. Alright, and that's all it means to evaluate a function. It means to take the number that they give you and plug it in over there on the right side where the rule is. So the vocabulary can get a little confusing there. They might say evaluate the function. They might say find the value of the function. All they want you to do is take the number and plug it in for the x. Okay, then the last thing we're going to look at is something called the domain and range of a function. Alright, so domain is just all the x values. So all the x values that are in that relation or function. And range is just all of the y values. And when you write domain and range, because they are a set of numbers, in math we have something called set notation. So anytime we're writing a set of things, we put them inside these brackets. Alright, and you're just going to do your best to draw them. I don't draw them very well, as you'll see when we do examples in class, but just do your best to draw those little brackets around the set of numbers that are in the domain, and then around the set of numbers that are in the range. Alright, so if we go back to some of these examples, and I'm going to write the domain, I'm going to write all of the numbers that are in the x or domain side of the mapping. So I have negative 4, and I'm going to separate them with commas, negative 2, 0, 2, and 4, and then I need to put them in the little brackets to indicate that this is a set of numbers. All of these numbers are the domain of this function. And then the range, I'm going to do the same thing. So negative 1 is part of the range, 1 is part of the range, and 4 is part of the range. And I put them in my little brackets, and that's how I write domain and range. When you're writing domain and range, if there's ever a repeated value, you do not need to write it twice. So, for example, if I were going to do the domain and range for that table, I'm going to do it down here because that's where I have room. I would write 2, 5, 6, and then I do not need to write 6 again. I just put it in brackets. Even though it appears twice, I don't have to write it twice. And then the range would be 6, 7, 9, and 10. From a graph, you would do the same thing. So these ordered pairs for the domain, I would write all of the x values. So this is an x value of negative 2. This one is negative 1. This one is 0. This one is 0, so I don't have to write it again. This dot is at 1, and this dot is at 2 on the x-axis. So my domain is just all of the x values. And I would do the same thing for the range, where I would write all of the y values. Now, sometimes, okay, the the domain and range aren't just a list of numbers, okay? Because if I look at this graph, it doesn't have just little dots. It's a line. It's continuous. So yeah, it has -1 as part of the domain, and yes, it has 0 as part of the domain, but it also has all of these little tiny decimal numbers in between -1 and 0. Okay, and there's no dot at the end. It keeps going forever. It goes forever this way, and this graph goes forever that way. When that happens, we say that the domain is all real numbers. Because then we don't just have a list of numbers that make up the x values. The x value could be anything, any number, because this goes forever and ever in both directions. So any number is part of the domain. So I'm going to show you a shortcut for writing this, okay? Now, I know that's what it looks like, but this does not say XER. All right, this stands for X. This is a symbol that means is an element of, and this R with an extra line in it means the real numbers. So this means X is an element of the real numbers. My domain is all real numbers. Any X value that you could think of, it's part of the domain. And we can do the same thing with the range. If I look at this graph, okay, it has y values that go up forever, and it has y values that go down forever. So instead of saying x is an element of the real numbers, if I'm talking about range, I'm talking about y values. So I would say that y is an element of the real numbers. Okay? All right, then we have two examples where they ask you to find the range of a function given the domain. So remember, range is output, all right, and domain is input. So they are giving you the input and asking you to find the output. So what I'm going to do, I'm going to take my function, f of x equals 2x minus 3, and I'm going to use each of these numbers as the input. So the first thing I'm going to do is find f of -2. I'm going to make my input -2. So I'm going to replace the x with a -2. And I'm going to find the value of f of -2. So f of -2 is equal to 2 times -2, which is -4. And then -4 minus 3 is -7. So part of my range, all right, is -7. And that's going to go in my bracket. Then I'm going to do the same thing with every single x value. So next I'm going to do f of -1. So I'm still using the same rule, 2 times -1 minus 3. Alright, so f of -1 is equal to, 2 times -1 is -2, minus 3 would be -5. So then I add -5 to my list of range. And then I repeat that process for f of 0 and f of 1. Alright, so what you're going to do, you're going to finish this problem. You're going to find f of 0 and f of 1, and then you're also going to do the next example. And then that will be it for our talk about relations and functions.